All right. So, since we have an exam during week 5, we are going to have another video lecture just like we did for week 4. So this is the video lecture that we're going to have. We're going to talk about rectangular coordinate system. How do we graph lines? How do we find equations of lines given some specific information? How do we find slopes, parallel and perpendicular lines? And then we'll talk briefly about angles at the end of this lecture. So we'll just get started. So rectangular coordinate system. So back in week 1, we looked at solutions to equations with just one variable in it, the x variable, right? So we were able to solve the equation for x. So sometimes we have equations in multiple variables. So if we think about our solutions in x, we end up with solutions that could fall on a single number. Right, if my solution is x equals 3, I can plot that on a number line. When we extend it to 2 variables, I need to create a second number line, which ends up giving us what we call the xy coordinate plane or the rectangular coordinate system. So that way we can see how points fall with a solution. When I have one equation and 2 unknown values, I actually end up with an infinite number of solutions, and the graph of that are the solutions. That's how we show the solution set. We show the graph of the equation. So we have these 2 number lines. We make sure that they are perpendicular to one another, and they cross at some point called the origin, which we denote as 0, 0, gives us an indexing situation right there. So each little value on the grid corresponds to what we call an ordered pair, which is an x value paired up with a y value where they satisfy the equation. So if we take a look at what the rectangular coordinate system is, most of you are probably familiar with this, is it's just a little grid looking thing just like this. So as we can see, if we take a look at this, it's kind of split up into 4 regions. And if we understand those 4 regions a little bit better, we can go through and figure out. We call them, each one of those regions, different quadrants. So we start on the top right, we call that quadrant 1, and then we work counterclockwise, quadrant 2, quadrant 3, quadrant 4. When we are in quadrant 1, both of our x values and y values are going to be positive. If I take a look at my chart right here, when I'm drawing my number line, usually as we go to the right, we end up with more positive numbers. So if we look at just our x-axis right here, we call it the x-axis. On the right side, I have positive numbers. On the left side, I have negative numbers. When we're dealing with the y-axis, the vertical axis here, if we go up, we use those as positive numbers. As we go down, we use those as negative numbers. So to the right, positive x, up, positive y, left, negative x, down, negative y. So if I'm in that first quadrant, both x and y are positive numbers. If I'm in quadrant 2, that means I'm left of the origin, but still above the x-axis. X is negative, y is positive. If I'm in quadrant 3, I am left and below the origin point. So x and y are both negative. And when I'm in quadrant 4, I am to the right on x sorry, right of the origin and below the origin. So x is positive and y is negative. So how do we plot points? We always take our ordered pair that we have, which would be written just like this, in parentheses, x value, y value. And then what we do is we start at the origin, which is this little circle right here. And I move myself the appropriate distance in the x direction, and then the appropriate distance in the y direction. So if my ordered pair is 4, 6, both of those numbers are positive. So I should end up in that first quadrant in the top right. I start at the origin here. I'm going to move 4 units in the positive x direction, which is to the right. So I move over 4 units, and then I need to move plus 6 units, or 6 units up in the y direction. So we do that, and we end up at this little blue point right here, and that's the point 4, 6. If my order pair is 2, negative 2, Well, x is still positive, positive 2. I'm going to move over to the right 2 units. Y is negative 2, so I'm going to end up moving down 2 units from there. So I move down right to where this red point is, and I end up with the point 2, negative 2. So that's how I plot ordered pairs on the XY coordinate system. So when we're graphing equations and we're trying to express the solution set as a visualization there, we're going to create the graph, and everything we're going to do in this class ends up being a straight line. One equation with 2 variables, we're going to end up with a straight line. So what we need to do is we need to figure out which points fall on that line so we can accurately draw it or portray the line. So what we need to do is we need to find x values and their associated y values that satisfy the equation or make it true. So if we take a look at y is equal to 3x minus 2, we see that the ordered pair 0, negative 2 will satisfy the equation. Because when I let x equal 0, this term goes away. I'm left with y equals negative 2. Therefore, when x is equal to 0, y is equal to negative 2, makes this equation true. So since that satisfies the equation, this will be one of the possible solutions to the equation and will be part of the graph of this equation. The ordered pair 1, positive 3 does not satisfy the equation, because when I let x equal 1, I get 3. 3 minus 2 is positive 1, not 3. So the equation is not true when x equals 1 and y equals 3. This does not satisfy the equation, so it does not fall on the graph of the line. Lastly, negative 1, negative 5. This does satisfy the equation, because when I plug in x equals negative 1, I see that y is equal to negative 5. We are good. So I continue to find the collection of these points so I can start visualizing what my graph looks like. Like I said, in this class, we are just dealing with linear equations, but this same process holds when we're dealing with more complex equations. If you ever have to deal with those things do show up a lot of times when we're dealing with real world information. So if we're ever dealing with situations where we have quadratic equations, logarithmic equations, things like that, we can still follow the same process by finding things that satisfy each equation. So in general, what do we do when we have an equation? So if I have y is equal to 3x plus 4, what I want to do in order to find values to this is I want to pick x values, and then I want to solve the equation for y. So for the first one, I said when x is equal to 3, let's solve the equation for y. So what I do is I let x equal 3, and then everywhere I see an x, I substitute in the value 3, and I solve, and I see what I get. 3 times 3 is 9. 9 plus 4 is equal to 13. So when x is equal to 3, y is equal to 13. So the ordered pair 3, 13 falls on the graph of the line. Next one said, let x equal negative 2. When I let x equal negative 2, I do the exact same thing. Wherever I see an x, I replace it with a negative 2, and I see what I get. 3 times negative 2, that's negative 6 plus 4. Negative 6 plus 4 is negative 2. So when x is equal to negative 2, I see that y is equal to negative 2. So that ordered pair will also fall on the graph of my line. We're going to do another one just to make sure. If we have a straight line, we only need 2 points in order for us to graph that equation, right? It's got to go through those 2 points. There's no other possible path it can go. We need a minimum of 2, but like we've talked about in class, we all make mistakes sometimes, and sometimes we might have just made a little mistake in our math. So it's always good for us just to find a 3rd point, just to make sure it falls on that line So we make sure we didn't make a mistake just using 2 points. So if x equals 0, I plug in 0 for x, and I get 0 plus 4. So y is equal to 4 when x is equal to 0. Therefore, my ordered pair would be 0, 4. On the next one, we have the equation written a little bit differently, but the process stays the same. I choose a value for x, and then I solve the equation for y. The only difference between this and the previous one is that my equation is not already solved for y. So what happens is I might have to do just a little bit extra math in there, one extra step, and then we'll be good to go. 3y plus 4x equals 18. Solving it when x is equal to 0, I substitute 0 in for x. And then my equation will break down in this case to 3y is equal to 18. And then solving that for y, I divide both sides by 3, and I get y is equal to 6. So when x is equal to 0, y is going to be equal to 6. That ordered pair satisfies the equation and will fall on the graph of our line. X is equal to -3. Same process. Substitute in -3 for x. And I go about solving this equation for y. 3y minus 12, 4 times -3 is -12, needs to equal 18. Solving this one for y, I'm going to add 12 to both sides. 3y is equal to 30 because 18 plus 12 equals 30. And then solving that for y, I divide both sides by 3, and I see that y is equal to 10. So when x is -3, y is equal to 10. Last one, we're going to let x equal +3, and we're going to see what we end up getting right here. So when x equals 3, this equation becomes 3y plus 12 is equal to 18. I'm going to subtract 12 from both sides, and I will see that 3y is equal to 6, because 18 minus 12 is 6. Solving that for y, divide both sides by 3, y equals 2. So when x is equal to 3, y is equal to 2. So the ordered pair 3, 2 satisfies this equation and falls on the graph of our line. So how do we make the graph? First thing we want to do is we want to create a table with 2 columns, x and y. We then want to find ordered pairs that satisfy the equation by selecting values of x and then evaluating y at those values, just like we did on the previous slide. Once we have a few points, we plot them on the xy coordinate plane to see what shape they are taking. In this class, they should make a straight line. And then we connect the dots in a smooth fashion, straight line. Again, when we're doing this process in the real world, we may end up running into a situation where we have a non-linear function. We can follow the same process, but hopefully we will have some additional education when it comes to those types of things. So suppose I have the equation y is equal to x minus 3. So the first thing I want to do is create a table x, y, and then I want to start populating that table going forward. I can pick whichever x values I want, and they should all be good and satisfy this equation. So I usually like to pick some simple values for x. X equals 0, 1, 2, 3, 4, 5. And then I plug them into the equation, and I see what I get. When x equals 0, I get y is equal to 0 minus 3. Y is equal to -3. When x is equal to 1, I get y is equal to 1 minus 3. X is -2. When x equals 2, y is negative 1. And I continue that process down until I have a couple of points. Again, we need a minimum of 2. Always good for us to have at least 3. Gives us just a sanity check that we haven't screwed up something. I then plot all of those points. 0, negative 3. 1, negative 2. 2, negative 1. 3, 0, 4, 1, 5, 2, all those dots right there. And then I connect a line that goes through all of them. The equation y is equal to 4x minus 3. Same process. I'm trying to graph it, create my xy table, pick some values of x, see what I get. As I'm taking a look at this, picking these values, I take a look. I always start with 0. I love starting with x equals 0. Makes my life simple because one of the variables goes away. And then I get 0, negative 3. When I let x equal 1, I get positive 1, 2, positive 5. And then I can also pick negative numbers. They don't all have to be positive. I can pick some negative numbers when x equals negative 1, y equals negative 7. So we can plot all of those points just like we learned earlier, and then we connect the straight line through all. So let's talk a little bit about intercepts. So when we're trying to find intercepts, we're basically trying to find the point at which the graph of our line crosses over the x-axis and the y-axis. So the x-intercept is the point which the graph of the line crosses the x-axis, and the y-intercept is the point at which the graph of the line crosses the y-axis. If I want to compute the x-intercept, I let y equal 0 and solve for x. If I want to find the y-intercept, I let x equal 0 and solve for y. Best part about finding intercepts is when we find intercepts, we're letting one of the two variables be 0, making it easier to solve for the other variable. So I told you we need a minimum of 2 points. If we choose to let x find the x-intercept and y-intercept, that gives us 2 points. Pretty easy for us to connect those dots. Then we can always find a third point just to make sure we didn't make a mistake. So given the equation 4x plus 2y equals 8, let's find the x and the y-intercepts. All right, so what I do is I create my table. And so we talked about earlier when we're finding ordered pairs, we let x equal something and we solve for y. It is just okay and just the same if we let y equal something and solve it for x. They should give us the same answer if the ordered pair is actually true. So I let x equal 0, I'm going to solve it for y. I let y equal 0, I'm going to solve it for x. When I let x equal 0, that term goes away, 4 times 0 goes away, and I get 2y is equal to 8. Solving that for y, I divide both sides by 2. Y is equal to 4. So when x is equal to 0, y is equal to 4. When I let y equal 0, this term goes away because 2 times 0 is 0, and I get 4x is equal to 8. Divide both sides by 4, x is equal to 2, so the point 2, 0 satisfies the equation. So my x-intercept is at the point 2, 0, and my y-intercept is at the point 0, 4. Next one, negative 2x plus 3y equals 6. Finding the x and the y-intercepts. I make my table. I let x equal 0, y equal 0. Solve for the remaining variable. X is equal to 0. That term goes away. 3y equals 6. Y must equal 2. When I let y equal 0, that goes away. Negative 2x equals 6. Divide both sides by negative 2. X is equal to negative 3. So my x-intercept's at the point negative 3, 0, and the y-intercept's at the point 0, 2. So let's find the x and the y-intercepts of the following equations. 3x minus 4y is equal to 12. So if we want to find the x-intercept of this, what I'm going to do is I'm going to let y equal to 0, and I'm going to solve my equation. So my equation now breaks down into 3x equals 12. Dividing both sides by 3, I see that x is equal to 4. So my x-intercept will be at the point 4, 0. If I want to find the y-intercept, I'm going to let x equal 0. So instead of letting y equal 0, I let x equal 0, and I solve this equation for y. So I'm left with negative 4y is equal to 12. Solving that for y, I get y is equal to negative 3. So my y-intercept will be at the point 0, negative 3. Not too bad for us to do. Let's do the next one. Y is equal to negative 2x minus 4. So this equation is just written in a little bit different way. And so when I'm trying to solve for the x-intercept, what ends up happening is, I just let y equal 0. So I have to solve this for solve this for x, which means I just have to do a little bit of extra math based on the way it's formed. So the first thing I'm going to do is I'm going to add 4 to both sides. 4 is equal to negative 2x. And I'm going to divide both sides by negative 2. So when I divide both sides by negative 2, I see that x is equal to negative 2. So now I have my x-intercept, which is negative 2, 0. And now I have to go about finding my y-intercept. So let's find our y-intercept here. So when finding my y-intercept, I let x equal 0, and I solve for y. So my equation breaks down now into y is equal to negative 4. Well, that sure was easy. Glad that happened. So when x is equal to 0, y is equal to negative 4. That is my y-intercept. So intercepts are often interesting for us to know. They have a lot of real-world applications. We're probably not going to discuss too many of those in this class, but they're valuable to us in the fact that they can tell us what value does my function take when x and y are equal to 0, because those might have real meanings in the real world. And they also give me 2 points that fall on the line. They're pretty easy to calculate. And I use those 2 points, I can understand the graph of my line of work. So sometimes we are interested in how steep a line is. So we take a look at lines. Let's go back and take a look at these 2 lines we did earlier. We have a line that looks like this, kind of looks maybe a little steep. Oh goodness, but not near as steep as this one, right? So we might say that this line is more steep than this line. So what we can do is we can find a way to mathematically compute how steep that line is by computing what we call the slope. So the slope is a numerical measure for the steepness of a line. It measures how much my line changes in the y direction as we move horizontally in the x direction. So we might have heard at some point in our math careers, slope is equal to rise over run. Rise, that's my vertical change. Run is my horizontal change. So if I'm taking a look at my graph right here, rise is from pick 2 points. From this point to this point, I'm going to 1, 2, 3, rise 3, 1, 2, 3, run 3. And that's going to give me a value of slope. I divide those 2 values to get my slope. So how do I find it given 2 points? Right, so we need to know 2 points that fall on the line, and we may or may not have the graph readily available. We don't need the graph, we just need to know 2 points that fall on that line. So if I have 2 points, first one's x1, y1, second one's x2, y2, we can compute the slope as follows. The slope is equal to m. That's what we use for the slope. M is equal to the rise over run. which is the change in y, y2 minus y1, over the change in x, x2 minus x1. So when we solve for the slope, we'll get a number associated with it, and that tells me how the slope changes. How much does my graph increase in y direction as we move over in the x direction? So let's talk about how we solve the slope of a line. So we have a line that goes through the points 1, 2, and 3, 6. So if we have the slope of a line that goes through these points, what we're going to do is we are going to pick one of the points, and we're going to call it x1, and we're going to call the other one x2. And I'm going to take the, x1, my apologies for that, x1, y1. So one of the points is x1, y1. We're going to let the other point be x2, y2. So we pick a point, let it be x1, y1. We pick the other point, let that be x2, y2. It doesn't matter which point I pick for x1, y1, and x2, y2, as long as I don't mix the points together. I can't try and pick things that look nice. I have to keep the ordered pair together as x1, y1. The other ordered pair together is x2, y2. So once I set this up, I'm just plugging numbers into an equation. y2, that equals 6. y1, that equals 2. So the top is 6 minus 2. x2 is equal to 3. x1 is equal to 1. So my bottom is 3 minus 1. 6 minus 2 is 4. 3 minus 2 is 1. 4 divided by 2, which is equal to 2. So the slope of this line is equal to 2. Let's find the slope of the line that goes through the points -3, -4, and 2, 1. So if I have negative numbers, no big deal. I'm just going to plug them into the equation and do the math just the same way. So we find x1 and y1. We pick the first point, let that be x1, y1. We're going to pick another point. We're going to let that be x2, y2. And then I simply just plug them into my equation that we have for the slope. In this case, y2 is 1. y1 is -4. So on top, I'm going to get 1 minus a -4. On the bottom, x2 is equal to 2. x1 is equal to -3. So up top, y2 minus y1 is 1 minus a -4. On the bottom, 2 minus a -3. 1 minus a -4, that's like a 1 plus a 4. That's a 5. 2 minus a -3, that's a 2 plus a 3. That gives me 5 over 5, which is equal to 1. So the slope of that second line there is equal to 1. Last one, slope of the line that passes through the points 4, 2, and 2, 6. I go about doing it the exact same way. Pick one of the points to be x1, y1. Pick the second point to be x2, y2. Simply just plug and shove into the equation. y2 is 6, y1 is 2, x2 is 2, x1 is 4. 6 minus 2 is 4. 2 minus 4 is -2. 4 divided by -2 is -2. So the slope is -2. So we solved a couple of examples, and we saw that the slope was positive. And now we just did one where the slope is negative. So if I have a positive slope, and we'll see some information on the next slide or two, all that means is direction for me. Everything when we're dealing with slope is moving to the right in the x direction. So if I have a positive slope, that means I'm moving to the right and up. If I have a negative slope, that means I'm moving to the right and down. That's all that means. The sign of the slope will come out when we're doing the mathematics. So there are four main types of linear graphs, and they all depend on the slopes. So there is a positive slope, which is y equals mx plus b, where when we solve it, our slope is positive. There is a negative slope. When we solve y equals mx plus b, and our slope is negative. There is a horizontal line. Horizontal line comes up when there is no slope. And then we have a vertical line. Vertical line is a situation where we have an undefined slope. We'll talk a little bit about those coming up. So let's take a look here. I know it's a little fuzzy, but these are the types of lines. Positive slope. As I move to the right, I move up. It's an increasing graph. So if my slope is positive, it's going to increase from left to right. Negative slope, as I move to the right, my graph moves down. So if I have a negative slope, I have a decreasing function from left to right. A horizontal line looks just like this third one here. The slope is equal to 0 because as I move over to the right, I do not move up or down. It stays constant. A vertical line has an undefined slope. Vertical line has an undefined slope. And the reason why it's undefined is because I cannot move to the right from it. Can't move to the right, can't move to the left, can't move horizontally. Therefore, we can't define the slope. Big difference there between horizontal and vertical. Horizontal, I can move right and left. I'm just not changing in elevation. Undefined slope, I cannot move right or left. I can only move up and down. So horizontal line, the equation will look like y is equal to b because my slope is 0, right? So this breaks down into y equals b. That is a horizontal line, no slope. A vertical line follows the equation x is equal to some constant value k. X is equal to some constant value k, and there is an undefined slope here. We can't quantify it. So we've seen some graphs, and we saw two forms of graphs earlier, right? We had graphs, or sorry, equations that look like y is equal to 3x plus 4. That's one way we use a graph. And then we had another form here, 3y plus 4x equals 18. This one, 3y plus 4x equals 18, is called standard form of a line. Y is equal to 3x plus 4 is what we call slope-intercept form of a line. So we call it slope-intercept form of a line because when we have the equation in that form, it tells us what the slope is and what the y-intercept is. So if y equals mx plus b, the slope will be the value of whatever m is, or the number in front of the x, and the y-intercept will be the value of b. So for example, if y is equal to 3x minus 2, the number in front of the x is the slope. So my slope m is equal to 3. And the y-intercept will be the value of b. I use negative 2, right? Because I have plus b, this is minus 2. So intercept is negative 2. So my y-intercept is a 0.0, negative 2. And if we go back up to this example that we did a little bit earlier right here, and we found the intercepts, when I found the y-intercept, we can see that I let x equal 0, and that term went away, and I was just left with y equals negative 4. Same concept holds right there. Might just save us a little bit of time because we'll know exactly what it is. So it doesn't matter what form my linear equation is in, I can put it into slope-intercept form by taking the equation and solving it for y. A lot of times we like to do this because it makes our lives easier and it makes more sense. Y equals mx plus b is just easier to visualize than ax plus by equals c. So what do? Suppose I have 2x equals 4, or sorry, 2x minus 4y equals 12, and I want to put this into slope-intercept form. So what I do is I solve this equation for y. I'm going to move the 2x over to the right, divide by -4, and I'll end up getting y is equal to 1/2 x minus 3. So our slope will be 1/2, our y-intercept will be 0, -3. Don't worry, we're going to do a couple of examples on the next slide. All right, so let's find the slope-intercept form of the following lines. So I'm actually going to do these on the board behind me so you can see me work these out. We can make sure we know what we're doing. So let's do it. I'm going to use my nifty-difty screen protector so you guys don't have this nice little glare right here. Do everything I can to avoid that, but fortunately, this is the easiest method for me to use. So let's take a look at the first one. We have an equation 4x plus 2y is equal to 6. So if I want to put this into slope-intercept form, what I need to do is I need to take this equation and solve it for y. So if I want to solve that for y, what I'm going to do is I'm going to get y all by itself. So I'm going to subtract 4x from both sides. So those go away. On the left, I'm equal to 2y. On the right, I'm left with 2y is equal to 6 minus 4x. Almost done to solve it for y. I'm going to divide both sides by 2. And I'm going to get y is equal to, little trick right here. If I have a plus b over c, I can rewrite that as a over c plus b over c, right? We learned about this. In order for me to add them together, I need to have them over a common denominator. So once I get to a point like this, I can just kind of work myself backwards, and it might help me simplify it a bit more. So that I can rewrite this as 6 over 2 minus 4x over 2. And now I can reduce those a little bit easier. 6 divided by 2 is 3. 4x divided by 2. 4 divided by 2 is 2. So I get y is equal to 3 minus 2x. Now this isn't exactly in slope-intercept form. So what we can do is I can just switch the positions of these two things. Flip them around, but the sign has to stay associated with the number. So I can rewrite this as y is equal to negative 2x, because I'm subtracting 2x, plus 3, positive 3 right there. So when I get my answer in slope-intercept form, I will get y is equal to negative 2x plus 3. Next one. Three x is equal to 2y plus 5. All right, to put this in slope-intercept form, I need to solve the equation for y. I'm going to subtract 5 from both sides. 3x minus 5 is equal to 2y. Then I'm going to divide both sides by 2. Those are going to cancel. Y is equal to 3x over 2 minus 5 over 2. So I would write this as 3 over 2x minus 5 over 2. Usually I leave things in terms of fractions. Sometimes our slopes don't work out perfectly. Sometimes our intercepts don't work out perfectly, right? This is the first time we've kind of seen that. In the real world, a lot of times we have to do fractions or decimals, more complex things than just nice whole numbers. So I wanted you all to see that for sure. All right, last example. 5y equals negative 2x. To put it in slope-intercept form, I have to solve for y. This equation is pretty easy for us to solve for y. We just divide both sides by 5. I get y is equal to negative 2x over 5. Y is equal to negative 2/5 x. That's it. That's how we put it in slope-intercept form. Now, let's go back and take a look at each one and identify the slope and the y-intercept. Y is equal to negative 2x plus 3. M equals negative 2. My y-intercept is at the point 0, 3. Easy peasy. My slope and intercept over here, slope, numbers attached with the x, is 3/2. And my y-intercept will be at the point 0, negative 5/2, because that is a minus sign. Last one, only a little bit tricky, but it's not really that tricky. M is equal to negative 2/5. My y-intercept, there's no term over here. And that's because we don't write 0 when it's just a 0. So when x is equal to 0, right, if I let x equal 0 here, y will also be equal to 0. So my y-intercept is 0, 0. So that's how we write things in slope-intercept form. So, simple example, find the slope going through the line, points 1, 2, and 3, 8. We talked about this a little bit earlier. We can find the slope of a line if we're given 2 points. Now, sometimes we don't know the equation of a line. All we know are 2 points that satisfy that line, or maybe we know the slope of the line in one of the points. So if we have a situation where I know some information about solutions, but I don't know exactly what the equation is, I can find it using the point slope form of a line. So the point slope form says, if I know what the slope is and I know a point, I can plug it into this right here, and I will have the equation of the line. So point slope form of the line is y is equal to y minus 1. Sorry, let me say that again. Y minus y1 is equal to m times x minus x1. I let m equal the slope, whatever that is, and then I plug in the other point as x1 and y1, and then I have point slope form of a line. So let's take a look at some examples with this and kind of how I would expect you to do a problem similar to this. So let's find the equation of the line with a slope of 4 that goes through the point 1, 3. And then we'll find the equation of a line that goes through the points 1, 2, and 5, 10. So we're also going to do these on the board, just so you can see, because it's going to take a little bit of work. Make sure we know what's going on. All right. So the first one is find the equation of a line that has a slope equal to 4 that goes to the point 1, 3. So if I have the slope in a point, I can use point slope form to find the equation. On the previous slides, I said it's always good for us to label our points. x1, y1, just to make sure I don't make any mistakes. If we have 1 point, it's a lot more difficult for us to make mistakes. So what I do is I just plug these values into my equation. That's not confusing at all. But I simply just plug in the values that I have. Y1, that's equal to 3. M is equal to 4. X is just X. X1 is 1. So this is technically point slope form of a line. Now that's not very user friendly. So a lot of times what we do is we take this and we convert it to slope intercept form. So all I do is I'm going to take this equation and I'm going to solve it for y. So I'm going to distribute my 4 there. So I get 4x minus 4. So y minus 3 equals 4x minus 4. And I finish it off by adding 3 to both sides. And I see that if I have a slope of 4, and a line that has a slope of 4 and goes to the point 1, 3, the equation of that line will be y is equal to 4x minus 1. So what that ends up doing right there is it tells me I know my slope is 4, it's right there. It also gives me that y-intercept value. So that's nice. What's probably more realistic, in a more realistic situation, is we end up with a place where we have 2 points that we know satisfy an equation. Because we can go out and we can just measure 2 points. We measure points, and we measure another point, we collect that data, and if we know it's supposed to be linear, we can fit a line to those, and we can find the equation of that line. So if I have an equation that goes through the points 1, 2, and 5, 10, first thing I want to do is label them. X1, Y1, X2, Y2. If I do that, I won't have any problems. All right, so I have 2 points. That doesn't help me with slope-intercept form. Point-slope form says I need to know a point, and I need to know the slope. Well, if I have 2 points, as we learned earlier, I can find the slope of that line that goes through those 2 points by using y2 minus y1 over x2 minus x1. So I want to find the slope of these 2 points right here. Y2 is equal to 10. Y1 is equal to 2. 10 minus 2. X2 is equal to 5. X1 is equal to 1. 10 minus 2 is 8. 5 minus 1 is 4. 8 divided by 4 is equal to 2. So I know my slope is equal to 2. So once I have a slope, I can come back and I can use point slope form. So in point slope form, I need to know the slope and a point. Guess what? It does not matter which point I use. My result will be the exact same when I convert it to slope-intercept form. So when I have the choice of 2 points, I always like to use the one that has the nicer numbers, not as big, usually positive if I can make them positive. They're both positive, but these are smaller values, so I'm going to use this one right here. So using this one, I'm going to get y minus y1, y minus 2 is equal to m, which we solved to be 2, x minus x1, x minus 1. So I want to solve this for y. Distribute the 2 on the right. I'm going to add 2 to both sides. Y is equal to 2x plus 0, but we don't write the 0. We know it's there, we don't write it. So when I take a look at this, I see that y is equal to 2x. That's the equation that goes through those 2 points. So my slope is 2, which we found it. That's a good thing. My y-intercept is that 0 that we erased. So y-intercept is the point 0, 0. So that's how we can use point slope form of a line to help us out in solving the equations of lines. So we talked about horizontal and vertical lines a little bit earlier. A horizontal line will follow an equation similar to y equals b, and a vertical line will follow an equation similar to x is equal to b. So let's talk about kind of what that means and what those are visually when we're dealing with it. So if I want to think about the line, y is equal to 2. When I create an xy table, I can let x equal whatever I want, and then see what happens to y. Well, y is equal to 2. When x equals 1, y is still equal to 2. When x is equal to, y is still equal to 2. Y is always equal to 2. So when I plot my points, I get 0, 2, 1, 2, 2. And I would continue plotting points as I went across here, and I would see that I just end up with a series of points that y is equal to 2. And when I connect those dots, I end up with a horizontal line. If I let x equal 3, well, x has to be equal to 3, and it doesn't matter what y is. So when I'm plotting these things, x is equal to 3, y is equal to 0. X is equal to 3, y is equal to 1. 3, 2, 3, negative 1. As I keep plotting these points, I see that they're going to fall straight up and down, and I end up with a vertical line. So that's a horizontal line, y is equal to something, vertical line, x is equal to something. And that's just how they happen to work out. So let's talk about parallel and perpendicular lines. So two lines are parallel to one another if they have the same slope. So if two lines have the same slope, they are parallel to one another. For example, y is equal to 2x plus 1, and y is equal to 2x minus 3. We see that both of those lines have a slope of 2. Same slope means they're parallel to each other. Parallel lines do not ever touch. Perpendicular lines, two lines are perpendicular if their slopes multiply to -1, or in other words, the slopes are negative reciprocals of each other. So when we're talking about negative reciprocals, I take the slope, I flip the fraction that I see, and I make it negative. So y equals 2x plus 1. My slope is 2. I'm going to flip it. Becomes 1 divided by 2. And then I make it negative. So the slope of a perpendicular line will be -1/2. So y equals -1/2 x plus 4 is perpendicular to y equals 2x plus 1. If I take a look at that, 2 times -1/2 gives me -1. That's how I'll know that they are perpendicular. Perpendicular, two lines that cross and form 90-degree angles. We'll talk a little bit about angles here. The x and y axes are perpendicular lines. So let's talk about how we can deal with this. So sometimes I know information about a line, and I want to find a line that might be parallel or perpendicular to it that goes through another point. So in this one, we're going to deal with an equation of a line that goes to a point that's parallel, and the equation of a line that goes to a different point that's perpendicular. So let's do those together. All right, so we want to find a line that is parallel to y is equal to negative 5x plus 4 that goes to the points negative 2, negative 7. All right, so for this one, we know the lines are parallel, and parallel lines have the same slope. So I take a look at this equation right here. The slope is negative 5. So that line parallel will also have the same slope, m is equal to negative 5. I know it goes to a point, negative 2, negative 7. So it has a slope that I know and a point that I know, which means I can use point slope form. So I plug in the information that I have. That's x1, that's y1. Y minus y1, y minus a negative 7 is equal to m negative 5 times x minus a negative 2. So now I can solve this equation for y. Y plus 7 equals negative 5 times x plus 2. We got rid of those minus negatives. Distribute. Negative 5x minus 10. Subtract 7 from both sides. Y is equal to negative 5x minus 17. So I take a look at these two lines. I know they're parallel because they have the same slope. So those two lines are parallel. This one will go through the point negative 2, negative 7. All right, for the perpendicular, the process is going to be just about the same. Perpendicular to the line, y is equal to 1/3 x plus 7, and we want it to go through the point negative 4, 2. So when two lines are perpendicular to each other, their slopes will multiply to negative 1, or they are the negative reciprocal. So to find the negative reciprocal of 1/3, I'm going to flip it. This gives me 3/1. And then I'm going to multiply it by negative 1. 3/1 is just 3 times negative 1 is negative 3. So my slope will be negative 3. So we're going to do that a little bit here just to make sure we understand the negative reciprocal aspect. 2, if I flip it, that becomes 1/2, and then I multiply it by negative 1. So I flip, and then I multiply it by negative 1. If I have 4/5, I'm going to flip, that becomes 5/4, and I'm going to multiply it by negative 1, negative 5/4. So in this case, we had 1/3. We flipped it to 3/1, which is just equal to 3. And then we multiplied it by negative 1 to get negative 3. All right, and I guess I'll do one more. If my sign is negative, so if we had negative 5, I would flip it. This gives me negative 1/5. and then I multiply it by -1. Now we get positive 1 over 5. So when we find the negative reciprocal, we flip it, change the sign, and we're good to go. All right, so we know our slope is equal to -3, and it's going to go through the point -4, 2. The parallel and the perpendicular aspects tell us what slope we're dealing with. The point gives us the point. Now we can use point-slope form of the equation to find it. Y minus y1, y minus 2 equals m, -3, times x minus a -4. And then I solve this equation for y. So when we do that, we see that y is equal to -3x minus 10. If I'm not sure if I have the negative reciprocal, I can take the slopes, multiply them together, and I should get -1. -3 times 1/3 is -1. So when we see that, we feel confident that we did it right. So let's talk a little bit about independent and dependent variables. Just so you're aware, the independent variable is always the x variable in the equation. And it's independent because normally we can make it whatever we want to make it. And it's something that we'll say it's almost uncontrollable by us. Y ends up being the dependent variable as it depends on what x is. So we kind of learn this notation that the x variable is independent, the y variable is dependent, and those applications actually extend out a little bit further. But for now, let's make sure we know what this is. All right, x variable, independent, y variable, dependent. We don't really talk about functions much in this class, but if I happen to have a function, then each x value will have exactly one y value. And in fact, everything we're doing here, because we're dealing with linear equations, they are all functions, and each input x value will have exactly one output y value. So that does it for equations of lines. We're going to talk a little bit about some points, lines, planes, angles, just so we're aware of what they are. So a point is just represented by a dot, no length, width, or thickness. When we plotted those ordered pairs, we were plotting a point. We represent it with a dot. A line connects at least 2 points, and it's the shortest distance between those 2 points. And the line extends infinitely in each direction. It has no thickness about it. So when we connected those points, we created a line. Those lines will extend infinitely in each direction. A plane is a flat surface with no thickness or boundary. Think about the whiteboard that we do our stuff on. Think about your computer screen. It's flat and plain. And a plane would, in theory, extend out infinitely in all 4 directions. And then a ray or a half line is simply just half a line. So if we take a look down here, we have a line that goes through 2 points A and B. It's a line I see because I see the arrows pointing out on each side. Tells me it goes out infinitely in both directions. So when we're writing that notation, we'll probably see something that looks like line AB with a line with 2 arrows over it. A ray or a half line, simply just half a line, goes through the 2 points A and B, but terminates at 1 point and extends infinitely in only one direction. We call that a ray or a half line. And when we write it AB, we put a line over it with only 1 arrow pointing to show that it's a ray. And then we have a line segment. A line segment is a segment of a line. it has two terminal points, A and B. So the line segment AB is the line segment that goes to the points A and B and terminates at those points. So just some notation you may or may not see. We'll talk a little bit about angles. So what's an angle? An angle, which is symbolized using that little symbol right there, is formed by the union of two rays that have a common endpoint. So I have a common endpoint B. I have a ray that goes from A to B or B to A. I have a ray that goes from B to C. And then they will form an angle right here in the middle. That little angle right there, denoted as alpha. One of the rays is called the initial ray. The other one's called the terminal ray. And that helps tell us what the direction is. Angles do have direction. We're not going to be too concerned about that in this class. We're just going to assume everything kind of goes in a positive direction. So we have initial ray, terminal ray, and then we're formed here. We have our angle. So there's a bunch of different ways we describe this same angle right here. First one, we might just call it angle alpha. I labeled it alpha. That's what we're going to call it. Second one, we might call it angle B, capital B, because it's the angle formed at the point B. We might call it angle ABC, which gives me direction, says I'm going from A to B to C. Or we might call it the angle CBA, angle formed from C to B to A. All of those notations correspond to that same angle. So angles are often measured in degrees. Example, 90 degrees. And a degree is defined as 1/360th of a full rotation. So there are 360 degrees in a full rotation. We probably know that 360 degrees in a circle. So if I have an initial ray and I place my terminal ray on the line that corresponds to 1/3 of a rotation, 1/3 of a rotation, I'm trying to figure out what that is in degrees. There are 360 degrees in one rotation. I'm only dealing with 1/3 of it. 1/3 times 360, that is a 120 degree angle. Let's talk about different types of angles. We have 4 different types of angles we'll talk about: acute, right, obtuse, and straight. An acute angle is an angle that measures less than 90 degrees. A right angle is an angle that measures exactly 90 degrees. An obtuse angle is an angle that measures in between 90 and 180. And a straight angle is an angle that measures exactly 180 degrees. So if it's less than 90, it's acute. If it's exactly 90, it's right. If it's between 90 and 180, it's obtuse. And if it's exactly 180, it's a straight angle. Complementary and supplementary angles. 2 angles are complementary to one another if they sum up to 90 degrees. So I can create a right angle here, which is a 90-degree angle, split off 2 different angles there. Those are complementary angles because when I add them up, they add up to 90. Supplementary angles, my straight angle is just a straight line. If I broke that up into 2 angles, A and B, those 2 angles would be supplementary because they add up to 180 degrees. Last thing we're going to talk about are vertical angles. When 2 lines intersect, opposite angles are formed and they're called vertical angles. So we're talking about opposite angles. I have angle 1 and angle 3. Those are opposite angles. They're vertical angles. 2 and 4, those are vertical angles. And vertical angles are equal to one another. So what this means is if I take a look at this, if I have 2 lines that intersect, angles 1 and 3 will be equal. Angles 2 and 4 will be equal. Angles 1 and 2 will be supplements because they fall on the same line. Angles 2 and 3 will be supplements because they fall on a line. Angles 3 and 4 are supplements, they fall on a line. Angles 1 and 4 are supplements because they fall on a line. So what is most important? You might notice we didn't really do any examples on this. There's plenty of examples that we could do. The key thing that I want you to know, or that you need to know for your exam, are the different types of angles that we happen to see. Make sure you understand that if we show you an angle or tell you we have an angle that measures this, what type of angle is it? You know what it is. Acute angle, less than 90. Right angle, exactly 90. Obtuse angle, between 90 and 180. Straight angle, exactly 180. I'm going to draw those on the board so you can visually see what those look like. Make sure we understand that concept. So if I have an acute angle, is going to look something like this. This might measure out to be 45 degrees. That's an acute angle. A right angle is 90 degrees, which is 1/4 of a rotation. Right? If 360 is 190 is 1/4 of it. And when we have a right angle, we usually draw in this little box right here. This lets us know that our angle is a right angle. Obtuse, it has to be larger than 90. So it'll look something like this. Maybe 120. And then the last one was a straight angle. And a straight angle is just a straight horizontal line, measures 100 meters. So let's make sure we know those well. All right, that's it for week 5. We'll have some more discussions about what's coming up in a little bit after this when we see each other during week 5. So enjoy.